Now let's do it if you used the other option whereby you chose positive downward. If you choose positive downward, which means everything that goes up will be negative, you will still use the same equation, VF squared. Guys, the direction is very much important. There's no way you can leave it out. If you leave it out, know that your answer is going to be wrong. So if you choose positive downward, which means your initial velocity must be negative, plus 2 times your acceleration, because it is always downward. Even if when the object is moving upward, the acceleration will be positive. Now your answer will be delta y. Your delta y, it's going to be 19.6 here, delta y. So because it is positive, when you move it to the left hand side, it's going to be negative. Then 120 when you square it, is going to be positive. Then your answer will be 734.69 meters, but you cannot leave delta y as negative. Then delta y will be minus 734.69 meters. Then, because the displacement is a vector quantity, you should also leave it as positive. The other way, instead of moving delta y, just move this 120 to the power of 2 to the right hand side. Then you do your mathematics correctly. Now let's move on to the next question. The next question says, sketch an acceleration time graph for the entire motion of the fuel unit until it reaches the ground. Indicate the relevant values for acceleration. This one is so easy. When you draw the acceleration time graph, we know that the acceleration is constant. But what is important when you draw the graphs? You must have the the axis. Your axis, you must have your axis. So it is acceleration time graph. So drawing the acceleration time graph, you must also indicate the variables, the independent variable and the dependent variable, and you should write them on the axis. And also you must write the heading, because sometimes you get a mark for just writing acceleration time graph. So we all know that time is always independently, so it will be on the x-axis, and also acceleration will be on the y-axis or vertical lane. Now, the other thing that is important when drawing a graph, you must also include the units of the variables. Now, we know that you chose your direction. So if you chose positive upward, it means your acceleration will be negative. So it must be clearly shown here. It is minus 9.8, and then you just draw the line that is parallel to the x-axis, because acceleration is constant. But if you chose positive, if your direction was positive downward, then your acceleration will be positive. So it will be 9.8 positive, and then you just draw that line there. Then that's how you draw your acceleration time graph. Now let's move on to the next question. The next question says, calculate the velocity of the fuel unit relative to the rocket's 5 seconds. Now you are given the time. After it is released, if the rocket has an upward velocity of 140 meters per second. So this one, we will just calculate the final velocity, because the challenge is we do not use the relative, the point of reference anymore. So let's move on. Now we will calculate our final velocity. So remember, the direction that you chose on the previous question, like on question number 2, you must continue using that direction. You cannot keep on changing the directions. On the next question now, you just choose positive, downward. No. The direction that you started choosing for the entire question must be the same. Now, we're going to calculate VF is equals to VI plus, because we are given time, it is going to be VI times delta T, and then our initial velocity is 120 plus 9.8. Remember the direction times 5. So your answer will be 71 meters per second. So the final velocity will be 71 point after 5 seconds. Let me just show you. From here, after 5 seconds, the velocity will be 71 meters per second. Remember, when the object is projected upward, the velocity decreases. Hence, at the maximum height, you will find that the velocity is equals to 0. Now, let's move on to the next question. The next question, here it is. I will give you 2 minutes just to go through this question fast, and then we will do it quickly after here. I know you do not have these questions that I'm having now, but now let's go through this question. The first thing that you need to do, each and every question that you come across, you must study it or read it carefully so that you clearly understand what is going on there. The question says, a ball of mass 0.2 kg is dropped. The other thing that I want to tell you is when you write the exam or when you practice, always have your pencil handy so that the words like dropped, projected upward, you should underline what you think is important. So it says a ball of mass 0.2 kg is dropped from a height of 0.8 meters onto a hard floor. It bounces to a maximum height of 0.6 meters. The floor exerts a force of 50 newtons on the ball. Ignore the effect of friction. Now, for this question, we are not given the sketch. So you must think with your head, with your pencil. When that ball is dropped, it means the ball was dropped from this height, we assume, and then it reaches the height was 0.8 meters onto the hard floor. So it reaches the floor. So when after it reaches the floor, it bounces. So which means it bounces off to the maximum height of the height will be 0.6 meters. The floor exerts a force of 50 newtons. The floor at this point, it means that the floor exerts the force of 50 newtons. Remember, when the ball is being dropped, and then when it reaches the ground, there will be a force that will be exerted on the ball to make it to bounce it again. And then ignore the effect of friction. First question, write down the magnitude and the direction of the force that the ball exerts on the floor. Wow. Guys, we have the answer in front of us. So the answer for question number 1 will be, the force will be 50 newtons. Just look at the marks that you are given, the ones that you should not forfeit. And then the question is, and direction. It is 2 marks. You'll get 1 mark for writing 50 newtons, but now what is the direction of the force that the ball exerts on the floor? The direction will be downwards. Remember, when you look at Newton's third law, why do I say downward? When you look at Newton's third law, it says body A will exert force on body B and body B will exert force on body A, but in opposite direction. So our statement here says the floor exerts a force of 50 newtons on the ball. So which means the floor exerts the force of 50 newtons on the ball. So if the floor exerts the force on the ball, then the ball also exerts the force on the floor. So it will be the same, because now the only difference will be in opposite direction. So the floor exerts the force in upward direction, and also the ball exerts the force in a downward direction, but that force is the same. Let's move on to the next question. It says, calculate the velocity at which the ball strikes the floor. The ball was dropped from this height, and then let's just take up until it reaches the ground, because now we are required to calculate the velocity at which the ball strikes the floor. The first step, I said to you, you must be able to write down your data. You were given the mass. So when the ball was dropped, it was from the height of 0.8 meters. So which means our delta y is 0.8 meters. Then because it was dropped, remember I said to you, for each and every motion we will have the initial velocity. So our initial velocity at this point is 0. So initial velocity is 0. Then we are required to calculate what? The final velocity when the ball strikes the floor. So we want the final velocity. Now the ball is moving in a downward motion. Therefore, this is what we are required to calculate, and we now have our acceleration, which is 9.8 meters per second squared. Remember, they said to you, ignore the effect of friction. So this statement tells you that the ball is in a free fall state. Now,